Hi folks, this is Module 4 and we're finishing up. We're looking at Novice Problem Solutions 6 and 7. So let's see if we can go back to our workbook. Problem 6 is a hypothesis test, but it's a very special kind of hypothesis test. It's going to be something we call a paired t-test. Before we've been looking at t-tests with two variables. In this case, the variables are related to one another. They are the same subjects. This is what I like to call kind of a before and after test. We have a group of subjects, for example, we might follow them for a period of time and count the cavities that they get. Then we collect that data, then we follow them again for a period of time. This time we give them a special toothpaste, and then we count the cavities. So the subjects are the same in this case, and that's important because that allows us to make all kinds of assumptions that are going to be valuable in understanding the results. So we've got workers, 22 workers. We monitored how many successful projects each one of the workers had. And then in the second half of the year, that was in the first half of the year, in the second half of the year we offered an incentive. What we're trying to determine is the incentive effective in increasing the number of successful projects that they complete in the half year. So it's a before and after. Before we did not offer the treatment of the special incentive. After we do offer that. So let's find that test. First of all, where's our data? Our data's right over here. We can see that for observation 1 or subject 1, they completed 90 early on with no incentive, and then later 95. So there was an increase, and the same here. 85 before, 89 here. So we seem to see little bits of increases. If we calculate a summary statistic, the average here, we see that there is a difference of exactly one completed project. So it appears that it has made a difference, but we've got to be a little careful about making that statement. We just have a very small set of data upon which to base that kind of statement. Let's get formal about the analysis. So where do we find this test? Well, if we go to data, and if we go to data analysis, we can find the paired t-test here. It says, where's my data? The variable range, first variable range is shown here. Second variable range is shown here. And I do have labels in the columns. I also hypothesize that there is no difference. That's my null hypothesis, that there's no difference. Usually in a test like this, the alternative is almost always that there is a difference without stating which direction it's in. So it'll be a two-tailed test as opposed to a one. Here's my alpha. I've already put that in there. And let's put the results, let's say, not in 04. Yeah, let's put them over here, 06. Hit OK. Here's my outcome. Let's expand this a bit. So what have I got? I calculated the similar sorts of means. Where we go to look for whether or not this is a significant difference or not is in the area where we have our p-values. Here's a p-value for a one-tailed test. Here's our p-value for a two-tailed test. So let's compare that to an alpha 0.01. Oh, by the way, I set the alpha before to 0.05, so really have to change that in the analysis. Let's take that data again. Let's change that. Let's go to data analysis. Actually, some of these changes are pretty easy to make. It's already got the data in there. I want to make the difference here as 0.01. I hit OK. There's the new data, and here are the stats again. Very similar to what we had before, but we now can state as a result of this test that we cannot reject at the 0.05 level y because our one-tailed test is larger than the 0.05, and so is our two-tail, which is the important test that we're looking at here, which is the alternative hypothesis is the mean with no incentive minus the mean with incentive is not equal to 0. We're not selecting a direction. So you cannot reject on the basis of the alpha 0.1. We can do that in Excel, in Minitab. We can take our data to Minitab as we had it before. Here's our data. I go to stats. I go to basic stats. I can go to paired t-tests. I've already got the data in here. I've selected the columns that I want, here and here. I hit OK. Here's the information. And here's our p-value. P-value based on a two-tailed test. I could have done a one-tailed test if I'd gone into the options and changed it to a one-tailed test. All right, let's now go to the next problem, which is our last. This is a formula again. We're doing a form of regression here. In this particular case, you've got a regression between a independent variable and dependent variable. And you're trying to develop the regression formula. And your boss has a sense that this is a polynomial relationship. That is, that relationship is going to look like something like this. Y is equal to some beta coefficient times a variable. That's a linear relationship plus another beta coefficient, B2, times the same variable squared. And then finally we add a constant on the end of it. So that's what that kind of relationship looks like. So, and you'll see in a second, it's going to look a lot like our exponential, except different sorts of progression as values get larger. So let's get our data. Here's our data. We want to do a scatter diagram of this data. So we usually do when we do an analysis for fitting data. So let's go to insert. By the way, I'm going to grab the data first. Go to insert. And then here's the data that we see. Here's our graph. And you can see this is pretty well-behaved data. It's right along that kind of path there. I can right-click this. I can add a trend line. I then have some capabilities here, selecting the kind of trend line that I want. I want a polynomial of order 2. Why? Because we're squaring the variable x1. And then I want to display the equation and the r squared. And there we are. We now know that b1 is equal to 73,381. b2 is the constant in front of the squared variable, 0.3447. Be careful, don't mix them up. This is b2, this is b1. And then the constant is this very small number of negative, well, it's not a small number, it's a large number, 4e to the 6, so that's 6 zeros after that e, after the 4. Okay, because this is a positive. And it's a perfect relationship. So I just chose a relationship. I multiplied it out and gave you the data here. So it's r squared is actually very, very high. As high as it can be. All right, that is our final two problems in Module 4.